Hello students, welcome to the third part of this lecture series, module 5, water chemistry. So in this part we are going to see about sewage water treatment. Before we move on to sewage water treatment, let us look at some important terms which are found in sewage water treatment. The first term that we see here is dissolved oxygen. So dissolved oxygen, from the name itself we can understand oxygen present in water in the dissolved form, that is called dissolved oxygen. We know that in all water bodies like lakes, rivers, etc., oxygen is required. Oxygen is present in the dissolved form and it is also required for sustaining aquatic life. That is the significance of dissolved oxygen. Essential for sustaining aquatic life, that is dissolved oxygen content ideally should be greater than 7 ppm. Lower the dissolved oxygen, greater will be the pollution. So dissolved oxygen is also a measure of how polluted the water is. Factors that govern dissolved oxygen. What are the different factors that govern dissolved oxygen? Temperature. Higher the temperature, less will be dissolved oxygen. Higher the temperature, less will be dissolved oxygen. Higher the pressure, greater will be dissolved oxygen. That we already know. Turbulence. Turbulence means moving water and stagnant water. So when water moves, what happens is it dissolves more oxygen. So the dissolved oxygen content in turbulent water, that is moving water, will be greater than in stagnant water. Aquatic life. If aquatic life is present, dissolved oxygen can change. If aquatic animals are present, dissolved oxygen will be less, whereas if aquatic plants are present, dissolved oxygen will be more. Organic matter. If organic matter is present in water, then microorganisms will utilize dissolved oxygen to degrade this organic matter, and so dissolved oxygen will be less. Chemical reactions. If chemical reactions are taking place inside water, like oxidations or reductions or something like that, then dissolved oxygen content will be less. So these are the different factors that govern dissolved oxygen. So one important question: state the importance of measuring dissolved oxygen in water. Determination of dissolved oxygen. How can we find out, or how can we practically find out the dissolved oxygen content of water? That is determined using a method called Winkler's method, named after the scientist who discovered that. So in Winkler's method, what is done is potassium iodide is oxidized by dissolved oxygen, sorry. And this is titrated with sodium thiosulfate with starch as an indicator. So this is the basic idea behind this method, this determination method. Take potassium iodide, mix it with water, so the dissolved oxygen will oxidize potassium iodide, convert it into iodine. So iodine, when you add starch, iodine reacts to give a blue complex, and when you titrate with sodium thiosulfate, this complex will disappear. Okay. Potassium iodide reacts with dissolved oxygen to liberate iodine. Iodine forms a blue complex with starch, and on titration with sodium thiosulfate, the iodine reacts and the blue color disappears. So this is the basic principle here. Describe the procedure for determining dissolved oxygen of a water sample. So this is the basic idea. Now this does not happen directly, it happens only indirectly, because dissolved oxygen cannot directly react with potassium iodide. So we are adding some other reagents to that. Okay, so this is the basic procedure. Next term is BOD, biological oxygen demand. Okay, so what do you mean by BOD? BOD, the definition is like this: amount of dissolved oxygen required by microorganisms to degrade organic waste in 1 liter water under aerobic conditions at 20 degrees centigrade in 5 days. It's a very long definition. So dissolved oxygen required by microorganisms. Microorganisms, what they present in water, what they do is they will take this dissolved oxygen and they will degrade organic matter present in water. So how much of dissolved oxygen is utilized by this microorganism? That is called the biological oxygen demand. There are some conditions in 1 liter of water under aerobic conditions 20 degrees centigrade 5 days. These four have to be maintained. Okay, 1 liter aerobic condition 20 degrees centigrade temperature in 5 days. It takes 5 days for this measurement. So BOD is directly proportional to biodegradable organic matter. BOD does not assess all oxidizable matter. There are other matter also, like non-biodegradable organic matter may be present and inorganic matter may be present. So that is not considered in BOD. BOD is determined by estimating the dissolved oxygen before and after a decomposition period of 5 days at 20 degrees centigrade. So you have a water sample, you want to find out its BOD. What you do is estimate the dissolved oxygen, then keep it for 5 days at 20 degrees centigrade under aerobic conditions, and then again find out what is the dissolved oxygen. Subtract both these, we will get the BOD. So the formula that is used is like this: BOD is equal to initial dissolved oxygen minus final dissolved oxygen into dilution factor. Now what is this dilution factor? Suppose you have a water sample which is very less in volume, like we have only 20 ml of that. We cannot find out the BOD from that. So what we do is we dilute this with nutrient water. Okay, so if x ml of sewage water is diluted to y ml, then dilution factor is equal to y by x. Suppose you are not diluting, you are using it directly, then y by x is equal to 1. So BOD is equal to initial dissolved oxygen minus final dissolved oxygen. Okay, so this is the formula to find BOD. Define BOD, how is it determined? Give the significance. This is a question which is asked for the university examination. So define how it is determined, give the significance of BOD. BOD is directly proportional to biodegradable organic matter, that is the significance. Next term is COD. COD stands for chemical oxygen demand. Now what do you mean by COD? This is the definition for COD: amount of oxygen required to degrade all oxidizable matter present in water. Okay, it is a total, is the amount of oxygen. It is not dissolved oxygen. It is the amount of oxygen which can degrade all oxidizable matter present in water. And always COD will be greater than BOD. This is a general formula. COD is greater than BOD. Significance of COD is that we can assess all oxidizable matter present in water: biodegradable, organic, non-biodegradable, organic, and inorganic matter present in water, in wastewater, can be estimated using this. COD is determined by reaction of sample water with excess potassium dichromate solution in the presence of a catalyst. So what we are doing here is we are adding an oxidizing agent to water. Okay, the oxidizing agent is potassium dichromate. In fact, it is acidified potassium dichromate. We are using a catalyst also, silver sulfate. can be used as a catalyst. So what we do is we boil the water with this potassium dichromate, and the unreacted potassium dichromate is obtained by titration with ferrous ammonium sulfate. Okay, so we add a fixed quantity of potassium dichromate. That potassium dichromate will oxidize all the matter present in that water, and there will be some remaining potassium dichromate that is obtained by titration with ferrous ammonium sulfate. So you know the initial quantity, you know the final quantity, subtract them. That is the quantity of potassium dichromate which has reacted with the compounds present in water. So a known volume of the water sample is refluxed for 1.5 hours with a known excess of potassium dichromate and 50% sulfuric acid in the presence of small amount of silver sulfate as catalyst. So the water sample, we take a fixed volume, like for example V ml, boil, reflux with potassium dichromate, acidified potassium dichromate using silver sulfate as a catalyst for 1.5 hours. After that, it is cooled and titrated against ferrous ammonium sulfate of normality N. Okay, so you titrate that. Let the volume of ferrous ammonium sulfate solution consumed in the titration be V1 ml. So how much volume is required for titration? The volume of ferrous ammonium sulfate, let that be equal to V1. So V1 is the amount of ferrous ammonium or volume of ferrous ammonium sulfate required for the unreacted potassium dichromate. Okay. Now, what you do is you titrate this, you repeat the same experiment with pure water, distilled water, and titrate that also with the same ferrous ammonium sulfate. Let the volume of ferrous ammonium sulfate for this titration be equal to V2 ml. This is called a blank titration. Blank titration. Okay. So V2 will give you the volume of ferrous ammonium sulfate required for the entire potassium dichromate. Okay, V1 is for unreacted, V2 is for the entire potassium dichromate. If we subtract these two, V2 minus V1, we will get the volume of ferrous ammonium sulfate required for the reacted potassium dichromate. That is what we want to find out. How much of this potassium dichromate has reacted with the water sample? That is what we have to find out. That we get from V2 minus V1. And we will substitute that in this formula. COD is equal to V2 minus V1 into N into 8 into 1000 divided by V, where V1 is the titer value of the sample, V2 is a blank titer value, V is the volume of the water sample taken, and N is the normality of ferrous ammonium sulfate. COD, the result is obtained in ppm. Now all these dissolved oxygen, BOD and COD, they are obtained in ppm. So this is another important question. What is meant by COD? How is it determined? Explain its significance in sewage treatment. Okay, this is another important question for a university exam. Let us compare BOD and COD. BOD, biochemical or biological oxygen demand. COD is chemical oxygen demand. BOD means it analyzes or assesses the biologically oxidizable impurities only, whereas COD assesses all oxidizable impurities. Cannot assess non-biodegradable organic compounds and also inorganic compounds, but COD can assess both. And it's a slow process. BOD determination, it requires 5 days, whereas COD, it requires only 3 hours. Differentiate between COD and BOD. This is a regularly asked question for a university examination. Differentiate between COD and BOD. Now we move on to sewage water treatment. Okay, sewage water treatment. What are the objectives of sewage water treatment? Now you have some sewage water. These are directly sent into a water body, like it can be a lake, or it can be the river, or it can be even the sea. So when we do like that, there is a lot of damage to the environment. So we have to prevent that. The objectives of sewage water treatment are: make sewage inoffensive, remove all the odor causing. It has an offensive smell, we know very well, isn't it? So we have to first remove that smell. Then prevent destruction of aquatic life. When you are discharging it into a river or into the sea, the aquatic life present there should not be destroyed. To prevent destruction of aquatic life and reduce danger to public health. Even public health should not be endangered. So these are the three major objectives of sewage water treatment. Now, how is it done? What is done in actually a treatment method? First of all, solid contents are removed. Okay, there will be some solid contents in sewage water, solid and semi-solid, all these will be there. That has to be removed. Then all nuisance causing elements, all toxic compounds, compounds which cause smell, compounds which are dangerous to public health, all these compounds should be removed, and the character of water should be changed for safe discharge. We have to make this water safe. Okay, so make the water safe. These are the three basic steps that are done. The first one, remove solid contents, that is called the primary process. Second one, removing all nuisance causing elements, that is called the secondary process. And the third one, change the character of water, that is called the tertiary process. So three processes are there: primary, secondary, tertiary. Treatment methods are of two types, or three types actually. That is what I was telling: primary, secondary, tertiary. Primary, what is done here? The raw sewage is taken and it is first screened. Some screens are placed. It is allowed to flow through these screens. So the solid compounds will be removed, and then it is subjected to sedimentation. Sedimentation means you add alum and you allow it to settle, so all the colloidal impurities will get removed. This is the primary process. Okay, removal of solid and colloidal impurities. This is the primary process. Then you have the secondary process. What is the secondary process? Is a biological treatment process followed by sedimentation. So biological treatment, you are adding some microorganisms to this. These microorganisms will remove or will decompose the unwanted compounds. Okay, these microorganisms will decompose the unwanted compounds. That is called the secondary process. And then you have the tertiary process. In the tertiary process, disinfection, nitrogen stripping, etc. Some methods are done and the water is made safe to discharge into a water stream. It can be the river, it can be the sea, or it can be even a lake. These are the three processes: primary, secondary, tertiary. Explain the various steps in sewage water treatment. So these are the different steps. Each step you have to describe in one or two sentences. Secondary process or biological treatment process, that is very important. That is what we are going to discuss now. There are two types of secondary processes. One is called the aerobic process. The other is called anaerobic process. Okay. Aerobic process in the presence of air. For example, tripling filter process. Anaerobic process in the absence of air. For example, UASB process. This is what we are going to see. Before that, let us compare these two processes, aerobic and anaerobic. What are the points of comparison? One is in the presence of oxygen, other is in the absence of oxygen. One needs aerobic bacteria, the other needs anaerobic bacteria. In aerobic process, carbon gets converted to carbon dioxide, whereas anaerobic process, carbon gets converted to ammonia. Sorry, methane. And nitrogen gets converted to nitrates in aerobic. Nitrogen converts to ammonia in anaerobic. Example, trickling filter UASB. Now in aerobic process, the byproducts formed like carbon dioxide, nitrates, they cannot be used for other purposes. Whereas anaerobic, the byproducts formed methane can be used as biogas. So this is a comparison of aerobic and anaerobic process. Compare aerobic and anaerobic treatment process. Another important question for a university examination. Trickling filter process. So what is a trickling filter process? I told you earlier it is an aerobic process. So there are aerobic microorganisms and aerobic conditions are maintained. The carbon gets converted to carbon dioxide, nitrogen gets converted to nitrates. This is the basic principle of trickling filter process. Okay, aerobic microorganisms under aerobic conditions convert carbon to carbon dioxide and nitrogen to nitrates. Now how is this process done? So you have a tank. This is a tank which contains rocks or stones, and these are covered with aerobic bacteria. There is a provision for air flow. Okay. The sewage water is pumped from the bottom. It is pumped upwards, and using sprayers, it is sprayed down onto these rocks. So when it sprays down, what happens? The water trickles down these stones. That is why the name trickling filter came. This is something like a filter where water trickles down, and in that trickling process, the microorganisms will oxidize all the compounds. Like carbon, all carbon content gets converted to carbon dioxide, nitrogen content gets converted to nitrates, and at the bottom you get the treated water. This is the working of the trickling filter process. Principle is this one: aerobic microorganisms under aerobic conditions convert carbon to carbon dioxide and nitrogen to nitrate. That is the principle. This is how it works. So this is the trickling filter process. Question: describe the trickling filter process for water treatment. So you should write the principle, draw the diagram, and you have to write the working, the explanation. Next is UASP process. It's a short form for upflow anaerobic sludge blanket. Okay, upflow anaerobic sludge blanket. Now, here anaerobic microorganisms are used. Under anaerobic conditions, they convert carbon to methane and nitrogen to ammonia. This is the principle. Anaerobic microorganisms under anaerobic conditions convert carbon to carbon to methane and nitrogen to ammonia. Now the working. Here also you have a tank. The sewage water is fed through the bottom and it comes out through the top. Inside this there is a thick mass which is called the sludge, and in this sludge we grow the anaerobic microorganisms, anaerobic bacteria. Anaerobic conditions are maintained, so as the water flows upwards, the bacteria will react with the unwanted compounds present in this water and degrade them, and the gas, you get methane as the gas. The methane comes out, it can be tapped, removed, and it can be used as biogas. So this is how the UASB process works. So another important question, explain the UASB process for treatment of sewage water. This is a 5-mark question. So this is all about sewage water treatment.